This is tutoring for intermediate algebra at Raritan Valley Community College. So we're going to talk about section 11.1, quadratic functions and their graphs. So suppose I want to find a value for a function given a particular x value. So say I had this function here, f of x equals x squared minus 5x plus 12. I want to find the value of when x equals 3. So f of 3 equals, I plug in 3 for every x. So parentheses, you always want to put in parentheses around what you're plugging into for the x. So parentheses 3 squared minus 5 times 3 plus 12. So f of 3 equals, what is 3 squared? That's 9. Negative 5 times 3 is negative 15 plus 12. So f of 3 is going to equal, well, let's see here. 9 minus 15 is negative 6 plus 12 is 6. So f of 3 equals 6. Now suppose I have another function where it's g of x equals 3x squared plus 2x plus 4. So say I want to find, what g of x is when x equals negative 2. So g of negative 2 equals 3 times negative 2 squared plus 2 times negative 2 plus 4. So again, I plug in negative 2 for every x and put parentheses around the number which I'm plugging in for x. So g of negative 2 equals 3, negative 2 squared is 4. 2 times negative 2 is negative 4 plus 4. Now, right off the bat, I already know negative 4 plus 4, that cancels out. It becomes 0. So then g of negative 2 is equal to 3 times 4, which is equal to 12. Therefore, g of negative 2 is equal to 12. Now I want to find the value of a function from the graph. So, okay, I want to find f of negative 2 and f of 2. Well, f of negative 2, well, that means where x equals negative 2. Where does x equal negative 2? Right here. Where's the graph? Well, I have to go up 1, 2, 3, 4. So that means that f of negative 2 equals 4. Now I want to go back again and I want to look at, okay, finding f of 2. Well, where does x equal 2? Well, let's see. 1, 2. And where does the graph hit? I go down 1, 2, 3, 4. So negative 4. So that means where x is 2, y is negative 4. So that's going to be f of 2 equals negative 4. And now the last thing we're going to discuss is finding the vertex of a quadratic function. So we want to use the formula x equals negative b over 2a. So first off, what is my b here? It's 2, because it's always the number that goes to the x term. So negative 1 parentheses 2 over 2 times, well, what's my a? A is the leading coefficient with the x term. Now here, it's just 1. Even though it's divisible, it's still a 1. So 2 times 1. Negative 1 times 2 is negative 2. 2 times 1 is 2. Negative 2 divided by 2 is negative 1. So that means x equals negative 1. So that gives me the first coordinate of my vertex. To find the next one, I had to plug in negative 1 in for every x. So f of negative 1, again, I put in parentheses, wherever I'm plugging in the value in for x, negative 1 squared plus 2 times negative 1 plus 5. And f of negative 1, well, first off, negative 1 squared is 1. 2 times negative 1 is negative 2. Plus 5. Well, 1 minus 2 is negative 1 plus 5. And negative 1 plus 5 is equal to 4. So that means f of negative 1 is equal to 4, or We can say it's, or, you know, it's the vertex V, which I'll label it V, is negative 1, comma 4. Now this next one's a little bit trickier because it's not in standard form. We have g of x equals 5 minus 4x plus 2. So we have to be careful. So again, we're going to use x equals negative b over 2a. So negative 1, where is my b? With the x term, negative 4. So negative 1 times negative 4 over 2. And what is my a? So the x squared term. It's 1 there, even though it's invisible, it's still a 1. So let's simplify. Negative 1 times negative 4 is positive 4. 2 times 1 is 2. 4 divided by 2 equals 2. So x equals 2. So to find the other coordinate, well, I have to plug in 2 for every x. So g of 2 equals 5 minus 4 parentheses 2 plus 2 squared. So g of 2 is equal to 5. Well, negative 4 times 2 is negative 8. 2 squared is 4. Now let's keep adding it. 5 minus 8 is negative 3. Plus 4, well, that's going to make 1. So g of 2 is equal to 1. So that means the vertex V for this quadratic is at the point 2, 1. I hope this video helps, and see you all next time. Bye-bye.